Hi friends, in this video we are going to discuss about the how to solve the problems by using current division rule if suppose the given network or circuit consisting of two nodes. Okay, now for example in this problem we are having, for example we are assuming this is the node 1 and for example this is the node 2. Now voltage source is here and our target is to find the value of current which is flowing in the 10 ohms. Now we need to find the current flowing in this 10 ohm resistor. Now how to find means, so in order to find the current flowing in 10 ohms, first we need to find how much amount of total current is available at junction point 2. If you know the total current available at this particular junction point 2, then we can easily apply current division rule to find the value of current flowing in this particular 10 ohms. But how much amount of total current available at this particular junction point means the total current available at junction point 2 is the current which is coming from this particular junction point 1. It means when the total current available at this particular junction point, so from this particular total current, some amount of current will divide in this branch and some amount of current will divide in this branch. It means the current flowing in 10 ohms means the current which is divided in this particular or current which is flowing in 6 ohms, which is divided from the total current available at this particular junction point. It means in order to find the current flowing in 10 ohms means first we need to find the total current available at this particular junction point 2, and the total current available at this particular junction point 2 is the current which is coming from the junction point and which is divided from the junction point 1. So that is the reason why first what we need to do, first we need to find the total current which is flowing in the given network, and after getting the total current we need to apply current division rule at this particular junction point 1 to find the current flowing in 6 ohms. And after getting the current flowing in 6 ohms, if you know the current flowing in 6 ohms, then that current which is flowing in the 6 ohms is the incoming current for the junction point 2. It means the total current available at the junction point 2 is the current which is divided from the total current available at the junction point 1. Okay, so for that first we need to find the total current which is flowing in the given system. Now total current is equal to, so total voltage divided by total resistance, or we can also call it as equivalent resistance. Now here total voltage is directly we can say that the applied voltage is total voltage. But coming to the total resistance, how to find the total resistance? We need to find the total equivalent resistance from the given network first, and after that we are going for the calculation of total current. So here whenever we are going for the calculation of total resistance in the given circuit, so first we need to identify whether the source is connected in the left side or right side. Now if the source is connected in the left side means, so we need to get the resultant resistance, always we need to start from the right side. Now see here 8 ohms and 10 ohms both are connected in parallel. Now to get the resultant of this one, so total resistance of the resultant resistance of the 8 and 10 ohms, that is 8 into 10 divided by 8 plus 10. If you are going to simplify this one, so 8 into 10, it means what? 80 divided by 8 plus 10 means you will get 18. So that is equal to, so 80 divided by 18 means you are going to get the value of resistance as 4.44 ohms. Now this particular 4.44 ohms is the combination of these 8 and 10 ohms. Now what I am doing, I am going to replacing this particular resultant value instead of the parallel combination of 8 and 10. Now see here, so this is the resistance 2 ohms and this one is the voltage source, and this 4 ohms is I am drawing the same as this, and coming to the 6 ohms, so this is also same. So this is 6 ohms, this is 2 ohms, this one is 4 ohms, and V is equal to 10 volts. Now what I am doing, instead of this parallel combination of 8 and 10 ohms, I am going to placing this the resultant value like this. Just see here. So the resultant of this parallel combination is 4.44 ohms. Now after completion of this, now see 6 ohms and 4.4 ohms both are connected in series. Now how to find the resultant of these two? So 6 ohms and 4.44 both are connected in series means we can directly add these two values. Now here, so you are going to get the 10.44 ohms is the value of resultant of series connection of 6 and 4. Now if you are going to redraw the given circuit like this, just see here. So this is the value of, so this one is the 4 ohms and this one is the 2 ohms. Now resultant of this 6 and 4 we got, that is the 10.44. Now instead of the series combination of 6 and 4.44, I am directly substituting the value of, so 10.44 ohms here. Now after getting this one, now see 4 ohms and 10.44 both are connected in parallel. So both are connected in parallel means, so how we are going to simplify? So coming to here, so both are connected in parallel means the total resistance or equivalent resistance of this parallel combination is, so 4 into 10.44 divided by, so 4 plus 10.44. Now if you are going to simplify this one, so 4 into 10.44 means you are going to get the value as, so total resistance is equal to, so 41.76 divided by 4 plus 10.44 means you are going to get the 14.44. Now if you are going to simplify this value, that is, so 41.76 divided by 14.44, it will gives the value as 2.891 ohms. Now this is the resultant value of a resistance of the combination of what? Parallel connection of 4 ohms and 10.44. Now instead of this parallel combination of this 4 and 10.44, I am going to substituting this resultant value. Now see here, I am going to replacing this value in the, or I am going to redrawing the network. Just see here. So this one is the 2 ohms, this one is the 2 ohms, and this one V is equal to 10 volts. And instead of parallel combination of, so 4 and 10.44, we got the value as 2.891 ohms. Now instead of this one, I am directly placing the value as, so this one. Now instead of the parallel combination of 4 and 10.44 as, so 2.891 ohms. Now 2 ohms and 2.891 ohms both are connected in series. Now we can calculate the resultant of this series connection is how much? The total resistance of these 2 ohms and 2.89 ohms, it will gives, so 2 plus 2.891, because series connection means we can directly add the values. Now total resistance is equal to 4.891 ohms. Now this is the total resultant value of a resistance in the given circuit. Now what is our target? Our target is to find the total current which is flowing. That is, total current is equal to total voltage divided by total resistance. That is equal to, so applied voltage is 10 divided by, so 4.891. So if you are going to simplifying this one, so 10 divided by, so 4.891. So it will gives the value as, so 2.044. So this is the value of what? So total current. Now after getting the total current to 2.004 amperes, so what we need to do? Again we need to show this current in the actual circuit. Now see, so this is the actual circuit we are having. So this is the voltage source, and this one is the resistance, and so simply I am redrawing the actual network with the resultant value of total current flowing in the system. So this is the 10 ohms, so this one 8 ohms, this one 6 ohms, this one 4 ohms, this one is 2 ohms, and V is equal to 10 volts. Now whatever the current we got, this 2.044 amperes. So this total current is supplied by this 10 volts source. So that is the reason why this current will directly flowing through like this and it will reaches this point. It means the current available, the total current available at this particular node 1 point is 2.044 amperes. Okay. Now if you know this value, we can directly find the current flowing through 6 ohms by using the current division rule. Now what is the current division rule formula? So current division rule, or the simply we can say that I am directly writing here. So current flowing through 6 ohms, we require the current flowing through 6 ohms. So here the current flowing through 6 ohms is equal to, by using the current division formula, total current, that is the total current available at the junction point 1 is, so 2.044 into opposite resistance. Opposite resistance is what now? So opposite resistance is, so 4, because after junction point we are having so two different branches, that is 6 ohms and 4 ohms. But after 6, we are at the back side of 6 ohms, we are having 8 and 10 both are connected in parallel. So this is the reason why what we are doing, whenever we are going for the calculation of current which is flowing in the 6 ohms by using current division rule, we always consider the value of the parallel combination of 8 and 10 also. So just see here how I am writing here. So the opposite resistance is 4. The opposite resistance is 4, and the divided by the total resistance means 4 plus 6 plus 4 plus 6 plus, and the combination of 8 and 10. Now here see 4 is the opposite resistance, divided by total resistance means 4 plus 6 plus the combination of 8 and 10. So if you are going to simplifying this one, so you are going to get the value as, so here, so 2.044 into 4 divided by 4 plus 6, how much? 10, plus 8 into 10 divided by 8 plus 10. So that is 80 divided by 18. Now here, so current flowing through 6 ohms by using current division rule is equal to, so 2.044 into 4. It will gives the value as 8.176 divided by, so here 80 divided by 18 means the value as how much? So the value as 4.44. Now if you are going to simplifying this one, so 8.176 divided by 10 plus 4.44 means you are going to get the 14.44. Now here current flowing through 6 ohms is equal to, if you are going to simplify, so 8.176 divided by, so 14.44, it will gives the resultant as 0.566 amperes. Okay, so this is the current flowing through what? This is the current flowing through 6 ohms. Okay, so it means the current flowing through 6 ohms is 0.566 amperes. Now this current is always starting from what? Node point 1, and it will directly reaches to node point 2. It means the total current available at the node point 2 is how much now? So 0.566 ampere is the total current available at the junction point 2. But our target is what? Current flowing through this particular 10 ohms. So that is the reason why if you are going to apply again current division rule in the 10 ohms resistance, then you will get the value as, so current flowing through 10 ohms is equal to total current. The total current available at this particular junction point 2 is, so 0.566 into opposite resistance is now only 8 divided by, so 8 plus 10. Now if you are going to simplifying this one, so you will get the value as, so 0.566 into 8 divided by 18. So here 8 divided by 18 means the value as 0.8 divided by 18 means the value is 0.444. Now if you are going to simplifying this value, so current flowing through 10 ohms is equal to, so 0.566 into 0.444, it will gives the value of current which is flowing through 10 ohms is 0.251304 amperes. Okay, so this is the final response of current which is flowing through the 10 ohms which is given in the problem. Okay, now here see the current flowing in the 10 ohms is equal to, so this particular resultant as what? So 0.251304 ampere of current is flowing through this path. Now you can observe here, if we are having two nodes, in the given circuit, means we are applying two times we are applying current division rule. But for example, if suppose we do not have the two or multiple number of nodes, then we can directly apply single time current division rule, then you will get the resultant. Okay, so like this we need to follow to get the response in any branch by using current division rule. Okay, so thank you so much for watching, and please do subscribe my channel and share with your friends. Thank you so much.